Let's do the next one. See, the question says, the motion of a particle executing SHM is described by the displacement function given by that. Well and good. If the initial t is equal to 0, position of the particle is 1 centimeter, initial velocity is omega centimeter per second, what are its amplitude and initial phase angle? This is the first part of the question. So, till here, you have the first part of the question. Alright. Then, the angular frequency of the particle is pi per second. If instead of the cosine function, if we choose sine function to describe the SHM, this one, what are the amplitude and initial phase of the particle with above, okay, fine. Because there are a lot of things to, go for this particular question. There are so many things, so many parameters. Let's break down the question. Alright. See, the first one, what you have is, it's given x of t is equal to a cos of omega t plus phi. Okay, let's break down the question. Let's figure out what is given to you, what is not given to you, and what you have to find out. Okay, see, if the initial position of the particle is 1 centimeter, that means here at time t is equal to 0, what do we have? X is 1 centimeter, correct? Because they are telling you that the initial position of the particle, that means x of 0 is 1 centimeter. What else is given? And its initial velocity is omega centimeter per second. Correct? Okay, what are its amplitude and the initial phase angle? Alright. Now what you have, so let's try to substitute the values whatever we have. So first, x of 0 is equal to a cos of omega into 0 plus phi. T value is 0, right? X of 0 is how much? 1. 1 is equal to a cos phi. See, what do you have here? A cos phi is equal to 1. Correct? Now that, see, till here all of you are clear, right? So, a cos phi is equal to 1. Next, what do you have? What are its amplitude and the initial phase angle? Okay. Angular frequency of the particle is pi per second instead of cosine. Alright, fine. Now what you do? You calculate the velocity, because we differentiate and we calculate and we try to do it. Okay, let's differentiate this one now. See, what do we have? We have x is equal to a cos omega t plus phi. So dx by dt becomes a omega into minus sine of omega t plus phi. This is what you have. See, dx by dt is what? Velocity, right? So v is equal to minus a omega sine of omega t plus phi. Again, at t is equal to 0, v is equal to omega, it is given to you. Next, so omega is equal to minus a omega sine of omega into 0 plus phi. Make sense? Now, omega is equal to minus a omega into sine phi. Now what you have is that, see, omega is equal to this, omega cancels, correct? Now what you are going to get is that a sine phi is equal to minus 1, correct? Now a cos phi and a sine phi, we figured out that a cos phi is 1, a sine phi is minus 1. Now square and add to get the amplitude. Okay, square and add in the sense a cos phi whole square plus a sine phi whole square. 1 square plus minus 1 square. Now what you are going to get? A square cos square phi plus a square sine. Take a square common. You will get a square into 1 is equal to 1 plus 1 is 2. So therefore a value is going to be root of 2 centimeter. Okay, A value is root 2. That is, the maximum amplitude is going to be root 2. Now you need to calculate the phi, the phase angle. For that, divide one by the other. In the sense, we'll do A sin phi divided by A cos phi minus 1. Minus 1 by 1 is minus 1. A cancels. Tan phi is equal to minus 1. So phi is equal to 3 pi by 4. This is the value and this is the value. This is the initial amplitude and initial phase angle. Okay, the next part of the question we'll solve now. Suppose if we use sine function, okay, then what you're going to have, x is equal to b sine of omega t plus alpha. Again differentiate. So v is equal to b omega cos of omega t plus alpha. Again at time t is equal to 0. Whatever we did for cosine, do the same logic. Okay, and x value becomes 1, correct? X of 0 is 1. Next, what you have in this case, and v is equal to omega in this case, correct? If you use the same logic, then we are going to get b sine alpha is equal to 1, correct? Then if you differentiate this, then you will have b cos alpha is equal to 1. That means, remember, the first case, this is with respect to displacement. This is with respect to displacement. And this is with respect to velocity. Just like the previous one, whatever we had done, do the same logic. Now, displacement you have, velocity you have. First is what? Amplitude, right? Do the same thing. Do square, add. If you square and if you add, then this is going to become b square sine square alpha plus b square cos square alpha is equal to 2. So b square is 2. B is equal to root 2 centimeter. This is the first case. The next case is the value, correct? So in this value, you can say that b sine alpha, okay, let me write it here. B sine alpha divided by b cos alpha is equal to 1. So tan alpha is equal to 1. So alpha value is pi by 4 or 5 pi by 4. These are the two values of alpha. Okay, instead of cosine, if you take sine, this is how the function is going to change. Fair enough? In the next video, you will see another couple of problems and we'll see how it can be solved.